Welcome to InstrumentsDirect. Our program today is on the Dynasonics DXN Ultrasonic Hybrid Transit Time Doppler Flow Meter. What do you get when you mix a transit time meter with a Doppler meter, a computer tablet, put them all together, you get a hybrid of an ultrasonic transit time Doppler flow meter. Welcome to the DXN. Finally, something completely different in the world of ultrasonic flow meters. This technology is unique in that it can monitor closed full pipe applications of ultra pure liquid, regular water, sewage, and sludge with heavy solids, all in one box. So our program today is to review the DXN, how we measure flow, the basic setup, transducer installation, logging data, and if we have time, temperature. I did say this is a most unique technology, and it's a compilation of a couple things. One, we have an ultrasonic transit time flow meter, which is designed to work in ultra pure liquids, water, and sewage, but not sludge. So it works on clean liquids up to a couple percent solids by volume. In the same box is an ultrasonic Doppler flow meter. A Doppler flow meter is a device that works on heavy solids down to about 100 parts per million, 30 to 100 microns in size, and basically it works on sludge and sewage, but that's how clean it works. So how does these devices work in harmony? Well, first of all, let's break them in half. Let's look at the ultrasonic transit time flow meter. An ultrasonic transit time flow meter is a unique application, and just listen to the word ultrasonic transit time. Transit time flow meter analogy is man in a rowboat wants to cross this river. Okay, he gets in the river and you notice the current's flowing from left to right. Well, this carries him downstream across the river at a certain period of time. But when he comes back across the river, he has to come against the current. It takes him a longer period of time to transit across the river. So the differential between when he went across and when he came back, that differential is the coefficient we use to derive on how fast the river's going. So with the current, he goes across fast. When it comes back, it goes against the current. There's a differential. The faster the flow rate, the greater the differential. That's the coefficient we use to derive how fast the river is flowing. Now, if we were to apply the same theory of concept using a pipe, I've got a bird's eye view right here looking down across the top of a pipe, and instead of across the river, I'm ricocheting off the back wall. So, sensor on the left, I send a sound beam, blast across the pipe, bounce off the back wall to the sensor downstream. As you can see, the flow is going from left to right. The sensor on the right-hand side also blasts a sound burst across the pipe, reflects off the back wall to the sensor on the upstream side. The differential between these two, because the flow is going from left to right, is the coefficient we use to derive on how fast the liquid is going inside the pipe. Faster the flow rate, the greater the differential. Now, we can mount this on the pipe in different configurations. The picture in the lower right-hand corner is the exact example of the man in the rowboat. We usually use this in larger pipe size applications. This is referred to as the Z or the single path method. The upper right-hand corner, the V configuration, is actually what you'll see in the field most often because it's what we use in smaller pipe applications just because it's easier to do. Traditionally, you'll see this in applications in, say, 1/2 to 24 inches. And in this case there, we're sending a sound beam across the pipe, reflecting on one side, and it comes down to the sensor on the other side, and repeat that effort. Now, another thing an ultrasonic transit time flow meter really needs to do a good job is it has to have some straight run of pipe. The traditional flow rates that you'll hear from a long time ago, you need the traditional 10 and 5 or 15 pipe diameters of straight run of pipe for optimum flow performances with most flow meter technology. What you'll get is the picture on the left-hand side, and this is referred to as a symmetrical flow profile. And this is made up of a series of different elliptical shapes. These are defined as Reynolds numbers, and basically What they mean is if you have a symmetrical flow profile, the flow is the fastest the center of the pipe and the slowest near the pipe wall of the pipe, side walls of the pipe there. The shape of the elliptical field here is based upon the flow rate. That's not so much important, but what is important, if you were to draw a center line down this pipe, the top half of flow equals the bottom half of flow, then you're really going to get an optimum performance with most flow meters. This situation normally occurs when you have enough straight runoff pipe. Traditionally 10 to 15 pipe diameters and flow rates of 10 feet per second, this phenomenon normally occurs. Picture to the right, this is referred to as asymmetrical flow profile. And for example, in this case there I have flow coming up the pipe there. You notice the distance on the inside of this elbow is shorter and the distance on the outside of the elbow is longer. So you tend to get a tumbling effect after this elbow. So if you were to put your transit time flow meter right here, it probably would just error out and you wouldn't get any data at all. So what you need to do is go downstream your 10 to 15 pipe diameters and put your flow meter there for optimum performance. Moving on to the ultrasonic Doppler technology, which is completely different. Doppler flow meters are designed specifically for applications with suspended particles in the process stream. Very much like, say, a police radar gun. They go and zap your car as it comes by and gives reflection back and it measures how fast your car is going. Well, if there's no car, there's no reflection back. Using an ultrasonic Doppler flow meter, if there's no suspended particulate matter in the process stream, then there's no reflection back. Most ultrasonic Doppler flow meters, depending upon the manufacturer, need about 100 parts per million and anywhere from 30 to 75 microns in size. You need a reflection from that to get the signal back. So Dopplers are designed traditionally for slurry-like applications, sludge-like applications, or applications that don't have a lot of straight run of pipe and you can reflect off of turbulence. Dopplers are not designed to work in applications that have no suspended solids. For example, a cup of tea. Well, if you've got a cup of filtered tea, the liquid looks very opaque. You say, my goodness, look how dirty this liquid is. They're all into solution. There are no suspended solids. Just like a cup or glass of Sprite, it's clear and translucent, but there's a lot of suspended bubbles in there. The Doppler flow meter needs to have something to transmit its frequency, reflected back in order for it to work. So what we've done is we've put both of those theories of operation in one box. So if we break this down, the ultrasonic transit time flow meter is designed to work primarily for your cleaner liquid application. So it's going to work in your water, any aqueous application, the energy management, HVAC, chemical process, wastewater, cooling tower, power, petrochemical, irrigation, and the list goes on. So if you have a closed full pipe that doesn't have chunks of stuff in it, then the ultrasonic transit time technology is probably your application. Should you have an application that also has heavy levels of suspended solids in the wastewater, the sewage, sludge, slurries, mining, paper stock, dredging, and so on, or an application that goes back and forth, the ultrasonic Doppler can take care of your heavy solid application. And the hybrid is the back and forth function, where you can have both the transit time and the Doppler sensors on the application, or you have the ability to just put the transit time sensors on and do a transit time application, or just put the Doppler sensors and using the Doppler application. So this device got everything in the same box to do your whole gamut of liquid applications. The hardware is pretty neat, and this is where it's completely different. We have basically a computer, literally a computer in a box with a big tablet-like display. It's a little bit heavier than most portables. It comes in a carrying bag with a strap, but basically it has a big display here where you can actually monitor what's going on. On top of the box, and this is the top here, is where all your interconnections for your different transducers will go. And if you hold it straight out, these are the hand grips that you can put it, grab a hold of it. As I said, it's also in a carrying box. Here's the hardware connections. Again, looking down from the top of the box, you can port in your power and your different array of transducers. And as I said, what is completely different, this is a computer running on an XP platform. Got it? And what is unique about it is the way it processes a signal. It can take up to 200 samples a second. So this guy is really collecting data unlike anything else. So it's has the ability to really do some interesting signal processing for your transit time and ultrasonic Doppler technology. As I said, it's PC-like. It has a very big, robust battery. Here's a picture of the diagnostic screen. This device basically can monitor up to 9 hours with the screen off. Say you're doing a logging application. 6 hours with the screen in the bright position, and more 8 hours when the screen's in the low position. Review of hardware. We have an array of transducers. Picture on the left is the small pipe adjustable transducer from 1/2 to 2 inches. It's a 2 megahertz system. This is the DTT-SU. Picture on the top in the middle is the DXN. The DXN is a 1 megahertz transducer, and it's used traditionally for medium-sized pipe applications. 2 inches and up, traditionally 36 inches. You can usually do that in a V configuration. When you run out of signal, you go into a Z configuration. Bigger applications or heavier solids applications, again using a transit time technology to the right, is the DTTL, which is a 1/2 megahertz transducer, and so we use this traditionally with very large water-like applications. Need to go over to the Doppler mode. Well, the picture on the bottom is the transducer, the DT94. It's the traditional Doppler transducers that start at 1 inch and go up. Well, when's the last time you heard the word GUI interface for an ultrasonic transit time or Doppler flow meter? As we said, this device is very intuitive. It has a setup wizard, graphical instructions. There is no need for a PC or any other software, and it has multi-language capabilities. As far as the logging functions itself, we'll get into that a little bit deeper, but it can store up to 1 gigabyte with an onboard SD card, and you download that with a USB cable. You can program up to 4 separate parameters of data that you'd like to log, and it can go ultra fast, the time sample to any time you basically want. So you can program the sample rate there. And again, as far as data that you can select, you could record the flow rate, the totalization, temperatures, if you have the RTD package, energy, power, sound speeds, and the list goes on. So what you see on the screen, you have the ability to check those individual items there. Then you'd store your data on a thumb drive. All these goodies come in a nice little carrying kit right here. So basically you get the carrying case and a shoulder bag. So there's a bag in there that encompasses with a window the handheld device. You can carry it around your neck so you don't drop it. Breakout I/O box, AC/DC, and a car adapter to run the device. Basic setup. Here we go again, the GUI controls. So here's the display. And doesn't this look like a computer? Again, it is. So this is the basic displays. As you see, the way navigation will drill it in here. If you get lost, lower right hand corner, home screen. Navigation menu to the left, navigation menu to the right, status bar in the lower left. Let's move over forward to there to review the status bar controls. If you click on the lower left hand corner, as you scroll through this, you can basically go for the flow meter quick status. It'll give you a flow rate and site name. Transit time status bar, the power activity, the setup wizard, the about us, and the shutdown bar. If you wanted to shut down the device, there's a slide switch there. Then we'll go basically in the setup of this device. If you've never read the manual, you can work this device. Basically, when you boot up the meter, there's 2 choices. You can go in a manual mode, or you can go in the wizard setup. And in the wizard setup, it basically goes through a series of steps of operation to get this device on the pipe. So although, yes, it's a computer, it's really not that complicated. So just like all ultrasonic flow meters, we need to program the application parameters and then put it on the pipe. So when you begin to set up the device, you need to create basically the site name and that you're working with. And this is helpful later on when you say pull it in to do some logging or to store data. And as that's the biggest problem, the things you have to grasp, because the data logging function is so large, you don't have to dump the data every day. So you're going to forget. So you actually have to spend some time and think about a format to create your tab. So in this case there, we're going to create our site, and then also at this level, we're also going to decide whether we're going to use English or metric. And after we create and name our site, in this case there, next we need to go over to the Fluid tab. In this case, it does have a drop-down menu of most of your common process liquids. So most of you people out there are going to use the water setting almost all the time. Generally speaking, if you have a unique process chemical there, it's probably on that chart. And then if you don't have it on that chart there, you can always give us a call. But generic rules of thumb for undiscovered properties, and remember we've got lists and lists and lists and lists of sound speeds of products, but if you have something that's been recently invented, a good generic default is to use the specific gravity as a generality to get you in the ballpark and how things work. Then the next step is to go into the pipe itself there. There's a database. You can go in the lookup tab to actually proliferate the information. So if you anything that's using an ANSI pipe chart that you know of, if you go in there and select the pipe material in the schedule, it'll actually pull up the pipe size information, or you can use a manual data entry system. So now that we have the pipe data in the system there, we have the process liquid in the system there, then we can move forward. Should you have a unique application like a ductile iron pipe with a liner on the inside of the pipe, again, this would be the point to put the liner information. You can drop in the various choices of mortar linings and so on, again, from the drop-down bar. So if we're using an ultrasonic transit time flow meter, then we will select the type of transducer based upon your pipe size. We showed you a chart a little bit before there on the drop-down. You'd select your type of transducer mounting, and then on the bottom of that, this is the key, will give you the required transducer spacing, the differential between the transit time transducers. As you saw, the man in the rowboat and the reflection off the back wall of the different configurations, they all had to have a specific trajectory, and you needed to know specifically where the pipe transducers needed to be mounted to receive and transmit those signals. The previous data you put in basically calculated out that information of all the different sound speeds. So it's very intuitive. You're not typing in the sound speed of water, 4,900 feet per second. You could if you wanted to. You're just putting in water. So it's doing the calculation for the water. It's doing the calculation for the carbon steel pipe and so on. So here's our spacing. It's 12.14 or 12 and an eighth of an inch. That would be the differential between the two transducers when you mounted it. If you go and want to use the Doppler tab, the Doppler is not sensitive to spacing. You would specify the Doppler transducer and you'd be all set up. So when we're done at this point, we're just going to press the Home tab and we're going to go back to the main screen so we can begin to read our data. We'll be able to monitor your flow rate and total flow. Now, as far as installing the device there, well, we just got the spacing for the transducers. On the transit time transducers, you will note that the dimension is not from butt end to butt end here. It is actually from this scribe line to this scribe line. So that's the differential points of an ultrasonic transit time flow meter. And note the transit time flow meter transducers, the cable outputs go in opposite directions as opposed to the Doppler transducers. So we go ahead and we got the spacing for our ultrasonic transit time flow meters. The next step, we need to go and prep the pipe. So if you have insulation on the pipe, you need to remove the insulation off the pipe. If you're going to loose material, you can wipe it off with a rag or a wire brush, but you don't need to take the grinder off. You don't need to take the plate off. If it's stuck on the pipe and rigid, you don't need to take it off. We need to put some acoustic couplant on the outside of the transducer. A very popular question, how much do I put on my transducers? Rule of thumb is toothpaste on a toothbrush. The sensor is flat, the pipe is round. We need an acoustic pathway to send our sound beam through. Let's go back with our friend in the rowboat. Well, he capsized. He's now standing in the lake and he's up to his waist. And he notices off in the distance his brother in the motorboat. And his brother in the motorboat, you can hear how far away his motorboat is. But if he put his head underwater, it sounds like the motorboat is right next to him. And the reason being, sound travels faster through a solid than it does through the open air. So sound travels faster through our acoustic couplant than it does through the open air. So that's the reason we need to have the bond on the pipe. You have to make sure you have the right type of a couplant. The DXN comes with 2 bottles of goop, as we call it. It's got one bottle of a water soluble, which is designed for like room temperature quick test applications. In addition to that, it's also got a tube, the F100, F100, which is in a silicone grease, which is a lot thicker, and it will stand the pipe at more moist condition applications and higher temperature applications. So depending upon what you're using it for, you have a different grease. As you visit our website, you find we have a whole plethora of different flavor grease for unique applications. So we grease up our transducer and we put it on the pipe. Well, if you have a horizontal pipe application, traditionally it's recommended that you put it on the side at 9 or 3 o'clock. And the reason being, 12 o'clock, there's some aeration, then there's some solids at 6 o'clock. So horizontal, keep that in mind. Vertical, it really doesn't make any difference. If you install a Doppler transducer that didn't have any specific spacing settings, but you did have to flip the switch on what transducer that you had, you still applied a certain amount of grease to the transducer, and you mount it on the pipe. Now, an ultrasonic Doppler transducer does not have a specific spacing requirement. Traditional applications are, the cleaner the liquid, we mount it transversely across the pipe at 9 and 3 o'clock. And should you have an application that has tremendous high level of solids, your sludges and your slurries and your mining applications, and you lose your signal, then you need to move the transducers side by side. Again, traditionally on the side of the pipe. Vertical really doesn't make any difference. Logging data. Well, this is where the setup comes back into hand, where when we tie this in together using the data logging function. So in this case there, we go to the Setup tab and we select the log group, and then we move on to the Select Data tab. We tap the Select Data tab to continue. In this case there, the column 0 is reserved for your preferred format of date time format. So you can select the format that you want to use to actually log your data. And then columns 1 through 4, you can select the specific type of data that you wanted to look at. So you want to look at flow rate, you wanted to look at totalization, you wanted to look at signal strength, you wanted to look at temperature, and so on. You have all the choices. Whatever's in the machine, you can select up to 4 different points to do that. Alright, so now your log is primed to initialize, but before you can do that, you need to go to the Create tab to pull up that project. There you go. That's why we needed to create some information before, so you can actually log that specific data, that specific application. So we go and collect that information, we pull up that create file to merge the two together, and then once that's all started, we can go ahead and record the site. Now again, the logging rate, you can adjust that to just about anything you want, to super duper fast speeds to as slow as you want. And then when you're done, you can open this all up on Excel. Now remember, in using Excel, if you use what we call the ludicrous speed, Excel chokes after you put so many data points in it, so you may have to chop up your files. Most people tend to use once a minute if you're doing an extended log, a daily log, a weekly log, or a monthly log. Remember, you get 1,440 data points in a day if you take a sample once a minute. So if you have a unique application, log as fast as you want, but you will get tons of data. So to retrieve the data, real simple, you plug in a USB drive into the port on top of the box. And then to download your file, we need to head over to the Systems Group tab. Again, doesn't this look like a laptop? And from the Systems Group, select the Storage tab, select the site relevant to your log file. So there we go to select the site to manage. And then what we do is we finish by copying site to USB. Boom. This is a computer that just confirmed it. So all your data is on your USB drive as a CSV file, and basically you go plug it in your laptop or PC, you turn on Excel, and you open the data. It's all there waiting for you. No more pulling out your hair to transfer data from your meter. If you wanted to have a 4 to 20 milliamp output, we do have a module that comes standardly with the device. It plugs in to give you your 4 to 20 milliamp output. Should you want the optional temperature energy management kit, You plug that in to your I/O output, and basically the optional temperature kit, you get a couple of strap-on RTDs. In this case there, you would monitor flow on the supply, temperature 1 on the supply, temperature 2 on the return, and collect all that data, and the device will actually give you an energy or BTU output. So that's a very popular application now. So this device can monitor a whole host of applications. And just to recap, we're monitoring transit time flow, we're monitoring Doppler flow, we're monitoring the combination of the two, a hybrid application. And if you have them all interconnected, it usually defaults to the transit time. As long as the transit time flow meter, the Doppler turns off, and so on. And then in a function to that, if you want to actually do an energy management application, you can add the optional temperature kits to monitor for BTU as well. So in this case there, future improvements. This is a computer, boys and girls, so it can be upgraded. On the deck right now, they're going to upgrade additional languages. I think today is available English, Japanese, and Russian, and another dozen languages are going to come out in the very near future. More temperature transducer diagnostics, more Ethernet connectivity, more debugging and test reports, and more peripherals. Thickness gauge is coming up shortly, and on and on and on. And what about us, InstrumentsDirect? We've been around for a long time. We have a significant amount of experience in the world of ultrasonic flow meters, and we make the DXN available to you by purchase and by rental. Information on the DXN will be located on our website. Learning videos are located under the, or training videos are located under the Learn tab. You'll find the DXN on their website. You'll find the operation manual, data sheets, and so on to support your needs. Should you have any need for cables or acoustic couplant or greases, you'll also find this at InstrumentsDirect.com. Well, if you have any additional questions, please give us a call. Toll-free numbers up on the screen, and emails as well. Thank you very much for attending our training program today.